Okay, this is going to be a limiting review, limiting reactant review with molarity. So let's read the problem. If 500 milliliters of a 0.2 molar hydrochloric acid solution is added to 750 milliliters of a 0.2 molar solution of sodium hydroxide, sodium chloride is produced. Determine the limiting reagent. So remember, the first thing that we're going to do when we determine a limiting reagent is take our givens for each of our reactants and convert them to moles. Now, our given is a volume and molarity. Volume and molarity. And what you need to know is that whenever you have a volume and you're trying to get to moles, you need to take liters and multiply it by that molarity, which is moles over liters, because then liters cancel out and you're left with moles. So we need to take our volumes and make sure that they are in liters. And we also need to take our molarities and rewrite them as that fraction, moles over liters. So let's start with our first reactant, hydrochloric acid. So with hydrochloric acid, we are given 500 milliliters, which is the same thing as 0.5 liters, and we're going to multiply it by its molarity. That is 0.20 moles of HCl over 1 liter. That's what molarity means. And when we do that, liters cancel out and we're left with moles. And so when you do that math, it ends up being 0.1 moles HCl. All right, so that's our first reactant. Our second reactant is sodium hydroxide. We need to take what's given to us for sodium hydroxide and convert it to moles. Again, because we are given volume and molarity, we're going to multiply those together to get moles. We're going to take our volume and make sure it is in liters, 0.75 liters, because it's 750 milliliters. We are going to multiply it by the molarity, which is moles over 1 liter. The liters cancel out, and we're left with 0.15 moles of sodium hydroxide. So this is how many moles you are given for each of your reactants. 0.1 moles of hydrochloric acid, 0.15 mole of sodium hydroxide. So to determine which one is limiting, which one runs out first, we're going to choose one of our reactants and use our mole ratio to determine how much of the second reactant is needed for a complete reaction. So I'm just going to start with my moles of hydrochloric acid. And I'm going to say, well, if I have 0.1 moles of hydrochloric acid, I am going to say that because sodium hydroxide and hydrochloric acid are in a 1-to-1 ratio, for a complete reaction with as much hydrochloric acid we are given, you would need 0.1 moles of sodium hydroxide. This is how much is needed. This is how much is given. Well, we're going to compare those two numbers. We need 0.1 moles of sodium hydroxide for a complete reaction. We have 0.15 moles of sodium hydroxide given. Well, since our given is greater than what's needed, that tells us that sodium hydroxide is in excess, it has leftover, and hydrochloric acid is going to be our limiting. So we'll write that out. So 0.15 moles of NaOH given is greater than the 0.1 mole of NaOH needed. Therefore, NaOH is in excess and hydrochloric acid is limiting. The only thing that is different from the last unit is the fact that we used our molarities and our given volumes to get our moles. Please, 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 anytime you're given volume and molarity, multiply those two together to get your moles. Make sure that you always change your volume to liters, so you cannot use milliliters in this case, and rewrite your molarity as that fraction, moles over liters, so you can see that liters cancel out. That's it.